So now that you've learned something about inverse trig functions, and I know you remember everything there is to know about the Pythagorean theorem, we can solve right triangles. And solving means finding all the missing parts. So I have two examples for us to look at. The first one, I have the sides of my right triangle labeled 3 and 7. The hypotenuse is C, and my two angles, these are some Greek letters. The first one is alpha and beta. So we need to find alpha, beta, and C. And I just made these numbers up, so probably they're not going to be nice. So we'll round to tenths or hundredths. We'll see how it looks when we bring in our calculator. All right, so it doesn't really matter where you start. Pythagorean theorem is going to tell us C. So let's go ahead and do that first. So a squared plus b squared is c squared. So C, right, square root of a squared plus b squared. So C will be the square root of 49 plus 9. And I'm going to use my calculator because it's that kind of day. So C, square root of 58. And if we want to do a decimal approximation, oh, that rounds nicely to 7.6. To find the angles, I need to use some inverse trig. So there are a couple of, right, once we get C, you can pick any of your trig functions to apply. But since the two legs are given exactly, right, 3 and 7, I'm going to choose to use inverse tangent. And you can start with beta or alpha, and I'm going to take alpha. So here's how I do it. First thing I do is I say, okay, well, the tangent of alpha is equal to opposite over adjacent. So then I know that alpha equals the inverse tangent of that same ratio. Think about composition and the function and its inverse, so inverse tangent of both sides here. Inverse tangent of alpha gives you alpha, and inverse tangent of 3/7 is a number our calculator is going to tell us. So I'll go ahead and put my calculator up here. Let me see what that's going to do. Well, that looks pretty good. So most calculators are going to have right above their tangent key a second function option that's tangent raised to the -1, right? There's our inverse tangent. You'll want to check and make sure that your calculator is in degree mode. That's the easiest one to recognize. It'll do it in radians, but right, radians don't seem as obvious to me where they are on my circle or in my triangle. So I happen to know my calculator is in degree mode. You can change it right here with the mode key. But mine's okay, so I'm going to go ahead and inverse tangent and then punch in my ratio. And that one rounds really nicely to 23.2, it looks like. So alpha is 23.2 degrees. And then to find that, I'll squiggle it, that third angle, I can just subtract from 90. I could do the inverse tangent the other way. It'll give me the same answer. But subtracting is a whole lot easier. And that looks like 66.8 degrees. All right, let's do one more example so that we have solved that right triangle. I'll write them in up here so you can see. So 23.2 degrees, and beta was 66.8 degrees, right, with obvious rounding. Okay, last example. So here's the new triangle. This time I know the hypotenuse and one angle, and I need to find the two legs and the missing angle. So let's see, the sum of the interior angles is 180 degrees. I've got 90, I've got 36. So I could find theta by subtracting. Right? So let's see, this is 90, so I have 90 minus 36. So what is that, 54? So 54 degrees for alpha, or for theta, right? Another Greek letter. Not sure how it came to be that we use Greek letters for angles, but most people do. So now I have all of my angles, but I have to find my sides. So let's see. What are some relationships I might know? What if I talk about the sine of 36 degrees? Right, that's a number my calculator can approximate for me. But in my right triangle, I know that that's equal to the side opposite, b, over the hypotenuse. So the sine of 36 is b over 20. Well, I'm looking to solve for b, so I can solve this equation for b. So multiply both sides by 20, and that'll give me b equals 20 times the sine of 36 degrees. And then it's a calculator problem. So again, make sure your calculator is in degree mode. Go ahead and scrunch that in right there, and you just type it in regular. 20, oh, not inverse, just regular. So times the sine of 36. 11 point, oh, that doesn't round nicely anywhere. I guess 11.8. Okay, 11.8 for the length of b. Oh, sorry. And you could either at this point use Pythagorean theorem, a squared plus b squared is 20 squared, or we could do maybe the cosine of 36, which is what I'm going to do. Cosine of 36 degrees is the adjacent over the hypotenuse, which means that the adjacent side is 20 times the cosine of 36 degrees. And again, in your calculator, 20 cosine 36 leads to, oh, that one runs much nicer, 16.2. And you could check with the Pythagorean theorem. It won't work out exactly that 16.2 squared plus 11.8 squared equals 20 squared, right? Because we rounded, but it should get pretty close.